4, it's called the chain rule. The chain rule has to deal with composite functions. So sometimes you don't have simple functions. If we'll look down here in the two examples, instead of just sine x, I've got sine of x squared. Or instead of just g of x equals 4x minus 1, I got 4x minus 1 to the 5th power. We could probably handle this with the power rule if we multiplied it out 5 times, but that would drive us absolutely crazy. So let's figure out how to handle a composite function with the chain rule. All right. If you have a composite function, what you do is you pretend that the function inside is just a simple x, and you take the derivative as normal. And then whatever function's on the inside, you multiply by its derivative later. So for example, and I know I can't cover this up real well, but we're going to pretend that this x squared is just a simple x. So the derivative of sine x would be cosine x. So we just bring this down like it was a simple x. Now, since it wasn't a simple x, we multiply by the derivative of the inside, the piece that was a little more complex. So the derivative of 2x, or I'm sorry, the derivative of x squared is 2x. So that just gets multiplied at the end. So your answer here, you'd probably put the 2x out front. It would be f prime of x is equal to 2x cosine x squared. Okay, same thing here. We're going to use an idea of the power rule. Pretend this whole bit here in the parentheses is just simple for a moment. So we're going to take the 5 and we're going to multiply by its coefficient. We're going to drop the 5 by 1 and make it 4. And then, since it's not a simple function, we look at the inside and we multiply by the derivative of the inside. In this case, the inside is linear, 4x minus 1, so its derivative is 4. So when we're done, we can combine the 4 times the 5, and we get 20 times 4x minus 1 to the 4th power when we take the derivative. Another derivative here in example 3, let's involve some trig for a moment. Please understand, whenever they write cosine cubed x, what it means is cosine x quantity cubed. So we're going to write it like this for a minute. And just like we did last time, we're going to use the power rule. Just pretend this cosine x is a simple function. 3 out front times cosine x, drop the power by 1 is squared. And now, since cosine x wasn't a simple function, we multiply by the derivative of the inside. The derivative of cosine x is negative sine x, so it gets multiplied. So if we clean it up a little bit, the end result is 3, and we're going to go ahead and drop the negative in this sine x out front, so negative 3 sine x. And then again, if we want to go back to the original notation, quantity of cosine x squared is just cosine squared x. This is how it's notated. All right, here are a few practice problems. So one, I just wanted to look at some ideas of, again, understand this is the graph of f prime of x. So the x-axis is here, the y-axis is here, and down 1, 2, f prime of x is actually the line y equals negative 2. Can you find the original graph? Now practicing a couple of chain rules. This one here, again, not a simple 1 minus 3x is not a simple function on the inside, so you have to find its derivative. Okay, you're going to use power rule, and then you're going to multiply by the derivative on the inside. This one's actually, I'm going to say, a little more complex. Please understand, you're going to use the quotient rule, but just take a moment and look at sine squared x up top. Sine squared x itself is not a simple function. So first I would do some side work, and I would find the derivative of sine squared x using the chain rule. And then once you do that, now see if you can find the derivative of h of x, understanding that you're going to have to apply the quotient rule here. That's enough for today. Thanks.